Hello, my name is Connor Blattner, a member of a team in INTEREGR 170 here at UW-Madison that was tasked with creating an air filter for the Wendt Labs laser cutter area. Our client, Matthew Mabey, reached out to us a while back with concerns about the laser cutters potentially releasing hazardous concentrations of volatile organic compounds and particulate matter into the surrounding area. This endangers all those that use the area.
As we take a trip over to the laser cutter area, we can clearly see that the area is of high activity, and every time the lid to the laser cutter is open, dangerous chemicals are released into the air. Our client has tasked us to come up with a solution that is within $150 and can fit in the small movable desk space. For a better look at the space, a 3D CAD model is provided on the screen. In addition, he has also requested that you utilize a specific HEPA filter that he has easy access to and can efficiently filter out PM sizes of 2.5 micrometers or more. After learning about our criteria and constraints, our group came up with 3 preliminary designs.
Design 1, the horizontal fan device, utilizes 5 PC fans laid horizontally, has an ABS plastic chassis, and is centered around fitting between the 2 vertical posts of the standing desk. The filter sits horizontally in the middle of the design and has fans both pushing and pulling air through it. Design 2, the PC fan design, also utilizes PC fans. It has 12 fans in 2 2x3 arrays to push and pull air through 2 centrally located filters. It has a chassis of plywood and has a chick wire mesh on the end of it in order to prevent large objects from getting in the filter, but not obstruct airflow. And finally, we have Design 3. Design 3, the centrifugal fan design, utilizes a centrifugal blower fan to blow air through a filter. It has a chassis made of ABS plastic and has its fan sitting above the floor.
Upon evaluating the pros and cons of each using the design matrix, we settled on the centrifugal design being the best, mostly because as a group, we were concerned about the static pressure of the PC fans. However, upon drafting a final design, we incorporated elements from multiple designs. The final design incorporates a plywood chassis, a centrifugal blower fan, 2 HEPA filters, and a complex electronic system consisting of a particulate matter sensor, SSR, and Arduino, which was connected in a system that could turn on the fan automatically.
When starting our fabrication process, we split our group into 2 groups of 3. One group focused on the construction of the chassis and integration of the fan and filters into the frame, where the other designed and created the electronic system that allowed the sensor to automatically turn on the fan. Throughout the fabrication process, we had multiple members regularly meet and consult with experts here at the Wendt Commons. They were crucial to the creation of our electronic setup for the air filtration system. In the end, we settled upon a small compact system that fit inside a small 3D printed box. The system has a VOC sensor near a small outlet in the box, which is then hooked up to an SSR to manage the difference in voltages between the fan and the sensor. This SSR is connected to an Arduino, which turns on the fan when the PM VOC levels become potentially hazardous. In order to create this, several different methods were used, including soldering, wire cutting, and more.
While our electronic system was extremely advanced and a central part of our overall design, it also had a large impact on our $150 budget. As a result, we were forced to change the material of our chassis from plywood to high-density fiberboard, which is a cheaper alternative. During the construction of the chassis, we also encountered several problems. One was the extreme shipping delays of our fan, which we needed for chassis construction, as the fan was meant to rest on a board that was cut around its unique shape. We then received news that due to issues with the shipping company, our fan would not be delivered at all this semester. As a result, we were then forced to modify our chassis once again. So if the client ever tried to order the fan, then we could install it in that design with ease. This forced us to make the chassis into 2 half-box pieces that are held together by friction, but can still easily be removed by our client to put the fan in. In order to achieve this, we used several different tools, including a 3D printer, wood glue, epoxy, and a sander on the HDF.
When testing our final product, we faced a variety of challenges as our fan was never delivered and hence we were unable to test the efficiency of our system as a whole. However, we were still able to test the individual components such as the chassis and the electronic setup. When testing our chassis, smoke are blown through the interior and leaks are identified and fixed immediately. When testing our electronic setup, we collected data from outside next to the laser cutter and a classroom located on the 3rd floor of Wendt Commons. And the data are compared by particle matters and the VOC concentration. Looking back at the project, we're proud of what we have accomplished. Despite experiencing several setbacks that's out of our control, we're still able to build a low maintenance product that meets all our clients' requests if the fan is purchased.